Hi and welcome to our video presentation case study for subject DCC30093 Geotechnical Engineering.
Hi, my name is Raiti binti Jeffrey, number matrix 07 DKA 23F2003.
Hi, my name is Rada Asai, number matrix 07 DKA 2023.
Hello, my name is Helicilla Charlens Dimos. My matrix number 07 DKA 23F2041.
Hello, my name is Annabelle Gracia Jo, and my matrix number is 07 DKA 23F and 2027.
The content of our presentation is include first introduction, second potential problems from shallow water table and soft clay, third suitable foundation type and justification, 4 impact of seepage and soft clay on strip footing, 5 seepage piping and consequences, 6 evaluation of foundation solution, and 7 post-construction cracks, causes and investigation.
Introduction. This report discusses a case study of two-story residential building constructed near a riverbank in a tropical region. The soil investigation revealed to a top layer of silty sand followed by a layer of soft clay with a shallow water table. Seepage problems were observed at the excavation site, raising concern about foundation stability and the effect of groundwater seepage on the basement structure. The report will address the potential problems, recommend suitable foundation types, analyze the impact of seepage and soft clay, and propose solutions to ensure the stability of the structure.
The site has a shallow water table and soft clay beneath the foundations, which can cause several issues. First, the soft clay is highly compressible, which can lead to uneven settlement and crack in the structure. Second, the shallow water table reduces the soil's bearing capacity, making it harder for the ground to support the building. Third, water seepage can wash away soil particles, a process called piping, creating voids and weakening the foundations. Lastly, these issues together can lead to long-term stability problems for the building. Due to the previously mentioned issue, selecting the appropriate type of foundations is very important. Because of these ground conditions, a deep foundations like pile foundations is more suitable. Deep foundations transfer the load to stronger soil or rock layer below the soft clay. This reduces the risk of settlement, avoids the weak upper layers, and perform better in wet soil. So, using a deep foundation is the safe choice to ensure the building remains stable and secure.
So the next one is the effect of seepage and soft clay on strip footing performance. As we know, soft clay has low bearing capacity, and according to Samaila Saleh 2021, weak soil such as soft clay have a poor bearing capacity, making them incapable of bearing the load of superstructures that will be imposed on them. So when a strip footing placed over such a layer, it is prone to excessive settlement or differential settlement, which can lead to structural damage such as cracks in walls or misalignments of doors and windows. And then there will be construction challenges, because the presence of seepage and soft clay can make excavation difficult, and it will lead to slumping of excavation walls and also increase the risk of accident or delays. Lastly is the risk of uplift pressure. So the seepage and shallow water table, which refers to the below ground surface of the building, where all of the soil and rock is fully saturated with water, and it can result in uplift, which is hydrostatic pressure under the basement slab, and it will cause it to be unstable or the water flow into the basement from the minor defect of the building. Seepage through the soil can lead to piping and soil erosion under the foundation. So seepage through the soil can cause piping, which occur when water flows with enough force to carry small particles away and form small channels or space beneath the foundation. Over the time, this process will weaken the soil structure and lead to void formation. Then, for the soil erosion, if there is continuous water movement through siltation or along the interface of soil layers, it can lead to internal erosion, where fine particles are washed out and it will reduce the soil density and support under the footing. And then, for the consequences, firstly, we have foundation settlement. Loss of supporting soil leads to sudden or progressive settlement, compromising structural integrity. Second one is cracks and tiddling. Uneven erosion may lead to tiddling or cracking in the foundation and superstructure. Third, flooding of basement. Seepage path can allow water ingress into the basement, leading to dampness, mold, or structural damage. Lastly, there will be complete failure. In extreme cases, piping can cause a catastrophic foundation failure, especially if the process is unnoticed over time. That's all from me.
Given the seepage issue and weak subsoil, evaluate the use of the following solution. One is use of a rough foundation. 2. Installation of cut-off wall. 3. Application of dewatering techniques. Which solution will be the most effective in this case and why? First, rough foundation. Spread load effectively over weak soil and minimize settlement, but not use controlled seepage. Requires additional waterproofing or drainage to handle groundwater. Number 2 is cut-off wall. Most effective solution. Block groundwater flow, directly reducing seepage and indirectly strengthening the soil by lowering water pressure. Offer a long-term fix if properly designed. Number 3 is dewatering. Temporarily lowers groundwater for construction purpose. Effective short terms, but not a permanent solution, and make a settlement in surrounding areas. For conclusion, the installation of a cut-off wall is the most effective solution as it directly tackles seepage and improve subsoil condition, offering durable and reliable ground stability.
Suppose after construction, cracks begin to appear on the ground floor walls. Assess whether the cracks could be due to settlement or seepage, and recommend an investigation method to confirm the cause. The possible causes for settlement. The presence of soft clay beneath the foundation may result in uneven settlement. Different settlement occurs when different parts of the structure settle at varying rates, causing vertical and diagonal cracks. Shallow water tables further reduce soil bearing capacity, exacerbating settlement issue. For seepage of groundwater into the soil can soften the clay and reduce its shear strength. Prolonged seepage may cause piping or internal erosion, weakening foundation support and leading to structural cracks. Seepage pads near the excavation site indicate that water flow could be undermining soil stability. Investigation methods. I recommend soil investigation, which is we have to collect undisturbed soil sample for laboratory testing to determine compressibility and strength. Second, site inspection and crack monitoring. Vertical cracks may suggest settlement. Random cracks could relate to seepage erosion. For site inspection and crack monitoring method, install crack monitors known as crack gauge to measure crack movement over time. Third, settlement monitoring. Place settlement plates or survey markers on the structure to measure ongoing vertical movement. And lastly, groundwater and seepage monitoring. Install piezometer around the site to monitor groundwater levels and pore water pressure. Perform a seepage analysis to trace groundwater flow path.